Good evening, students. Welcome to Sorts classes, and I will be your educator for organic chemistry and inorganic chemistry. My name is Dr. Sarkar. I did my PhD from IIT Kanpur and my postdoctoral studies from IIST Shirpur as a Dr. D.S. Kothari Fellow. Now, the topic that we are going to discuss today is as advanced organic chemistry disconnection approach. The topic is a part of your syllabus of CSIR. And I'll give you a little bit of a background how this approach came, this disconnection approach. Now, when organic chemists or bioinorganic chemists, they wanted to synthesize target molecules, okay, biologically active molecules, or they wanted to mimic an enzyme. So they wanted to first of all strategize how they want to carry out the reaction in a lab, depending what kind of reagents they have on the rack, and then make a scheme. And if one is lucky, okay, then one doesn't need to do a hit and try method much more times than one would do if you do not have a strategy. So if you have a strategy, you have your reagents available, you know which way to go around, okay. So let's see, now that's how the theory developed. So I will be discussing today alcohols, okay. I will be discussing acetyls, ketones, how you can get the starting materials of these compounds, and let's see and how much we can go ahead with this topic for today, okay. So if I suppose give you an alcohol, okay, and I mention this is your R1, that is your R2, that is your R3. Now R1, R2, R3, they are not equal, okay, and they can be R1 or R2 or R3, can be your alkyls or your aryls, okay. So I have defined that first for you. Now there is a OH bond. Now all you got to do, you can take it as a rule, you first try to disconnect this bond and try to bring it back and make a CO bond. That way your H goes as a H plus, okay. In terms of simple organic chemistry, you can say this is a heterolytic cleavage, okay. And at the same time, you can think I am taking out a R1, or I have the possibility of taking the R2, or I can take the R3 away as a carbanion, okay. That means R1 minus, R2 minus, and R3 minus. So if you do that, so I will be taking away one of it. Now the process is that while you are showing the disconnection, you use a arrow of this kind, and so here you write H plus, and then you have C double bond O. If I have taken the R1, then obviously R2 and R3 remain, and I get R2 minus. Now R2 minus, according to the disconnection approach as it has been developed, this will be called as a synthon. Okay. Now this is R1. Sorry. Now your synthon, from that you have to develop your reagent. Okay. So you know that ketones react with Grignard reagents to form tertiary alcohol. This is a tertiary alcohol. So what will I do? I will simply write R1 minus MgX. So that is one of my starting material over here. Now I will take a real life example. Suppose I have given you something like that. There is a methyl, and suppose there is a phenyl. And I've made a question for you, that what are the possible starting materials from which you can make this alcohol? Okay, same thing. Make the double bond. Say in root 1, I am taking away the ethyl. So this is your CH3, that is your CH3. So this is CH2CH3. So if I take away the ethyl, I will get Et minus, that is my synthon. the reagent will be Et minus MgBr, and along with that my alcohol will now be the pH CH3 double bond O plus H plus. Acetophenol is an available reagent in the lab. You can make ethyl bromide, magnesium bromide. So this is one of the possibilities. What is the other possibility? So this is my A, say suppose. Now if I will say this is A pathway. Now if I take away the methyl away, then what I can get over here? I will get CH3 minus, that will have the reagent CH3 MgBr, alright, and along with that I will have something like this as the ketone, and then you have H plus. So that is root way 2. Now if I think of taking away pH minus, I will call this as root way 6. So there you can have pH minus H plus. My ketone will be something like that. This is the synthon, and the reagent will be pH MgBr. So for synthesis of this tertiary alcohol, okay, or a 3-degree alcohol, not a tertiary alcohol, 3-degree alcohol, what I can say is I have 3 different possibilities by which I can do this synthesis. Okay, interesting, isn't it? So if I now go for the other alcohols, let's see. Can I apply this for any alcohol given to me in an examination hall? Okay, let's have a look. Suppose I have given you something like that. Okay, and I say, which is the best method to do it? Let's see. If you take away the hydrogen, you will be generating obviously a double bond, C double bond O. Now the point is, should I keep a phenyl and a methyl, or so that means I will be taking away one CH3. So here my synthon will be CH3 minus H plus, and the reagent for this synthon will be CH3 minus MgBr. Okay, so that is pathway, say A. Now if I take away the phenyl group away, I will say it is going to be CH3, CH3. So this is basically acetone, okay, highly available in the lab. And there we have a pH minus, obviously that is the synthon, and the reagent will be pH minus MgBr. That is your Grignard reagent, and along with that you have H plus. So if anybody had to make a question for me, or had a query, which would be the best way of doing this? Obviously the most available reagent would be acetone, so this is the best way of getting away with this reaction. Alright. So not only it gives you a strategy, method by which you can synthesize a molecule, but looking at the starting materials you're getting from here, right, you can decide, depending on the availability of that reagent in your lab, which is the best to go with, okay, for your reaction. So now this is all we can say about alcohol. Okay. Similarly, if I do not have alkyl groups but I have a hydrogen, what do I do? Suppose I give you something like this, pH, or say CH3, C, CH3, H, OH. Now in this case I do not have a alkyl group, rather I also have a hydrogen along with the alkyl groups. Now what will I do is, if I make a C double bond O like this, and I think One process is I will take away the alkyl away, so I get a CH3 minus. Obviously, that is the synthon. Then we have CH3 MgBr, the reagent for it, and CH3H, easily available in the lab. Fine. We can have this reaction method also. The other one will be, if I keep both these CH3s and I take away one of the hydrogens away as a hydride, then what do I get? Please have a look. You have CH3, so that is acetone. If you have a H minus, now if this is the synthon, what can be the reagent? Obviously you will say, sir, I have studied. You can have lithium aluminum hydride. Apart from that, you can have sodium borohydride. Obviously, if you have to make a choice between lithium aluminum hydride and sodium borohydride, you will say SBH, sodium borohydride, because it is less costly. Okay, that is from the research point of view, what reagents you can use so that your cost can go down. All right, and apart from that, you will say, sir, obviously this is H plus. Okay, now you have developed some amount of idea how to disconnect molecules and get the starting materials. Okay, and if you're having a synthon, then having the previous knowledge of the reagents that you have studied and how they function, you can develop a method by which pathway you will go with what reagents so that you can get a clean reaction. Okay, so far so good with the alcohol discussion. Let's look at some disconnection of acetyls and ketones. Okay. Now we know when you have an acetone, you have say something like a ketone like this, R, and R, H. So this is your aldehyde, that is your ketone. If you react this with excess amount of alcohol in dry HCl, mind it is not aqueous HCl, okay, and this is in excess amount. What is in excess amount? My ROH. This is a reversible reaction, so you need excess amount of reagent to push the reaction in the forward direction according to the Acetyls principle. Okay, so what you will get at the end is this and this. So here it is, we have been given ROH. Now if I give you something like that, okay, and this is in excess amount, again dry HCl, all right, so I can say I will get something like this. Okay, so this is obviously cyclic ketone, and this is non-cyclic ketone. And these are a good way of protecting ketones towards nucleophiles. That's why they are used a lot in research. Okay, so now if I was given any ketone, okay, if I was given say any ketone like this, okay, and I am asked what are the starting materials for this, how to go about this, okay, how to go about this. All you got to do is you have to find the carbon that is joined to two such oxygen. Once you have done that, what you could do is you disconnect these bonds, okay. Again, it is a heterolytic cleavage. That means an anion and a cation will be formed. Now, what will happen is you will put plus and plus charge, okay, because you have disconnected two single bonds over here, and similarly you have a O minus and a O minus over here. So these are your synthons. Now remember this because we'll be using this a lot more. What I am asking you to do, wherever you have this dipositive charge, you simply add O2 minus. Wherever you have a negative charge of electronegative atom, okay, you simply add protons. What does it give you? You have a OH, OH. So these are your synthons. This was your target material, which is named as TM. And if you add the oxygen, that is your ketone. Okay? So that is how you have to do this. Let's take another example. Suppose you have been given okay, something like that. Alright, so I'm going to erase this part because I need, sorry, I got a small board. So, now, let me erase it. It is something like this. So you have a OMe, you have a OMe, and there is a hydrogen. A simple question that you should ask yourself as a student of chemistry: is this a ketal or is this a acetal? How to decide? This portion is an alkyl. This portion is hydrogen. So obviously there are not two R's but one hydrogen and one alkyl group. So obviously this has to be an acetal. Okay. Alright, so let's go ahead. So I'll just apply what I taught you. We will be disconnecting, so I'm using a different ink over here. Alright. And then that is the arrow for the disconnection approach. Positive charge, there is my hydrogen, and I have OMe, minus charge goes over oxygen. And what did I tell you? Wherever you have this positive charge, dipositive charge, simply you have to add O2 minus, and over here you add H plus, and that will give you two molecules of methanol, and at the same time you will be getting the aldehyde. Obviously over here it is the propanal. Okay, so now we have got some idea about disconnection approach of acetyls and ketones. Now the next thing that I'm going to do for you is I will be taking you to alpha beta unsaturated aldehydes and ketones. Okay, so the topic is disconnection of alpha beta unsaturated aldehydes and ketones. All right. This is a vital reaction and it has been asked many times. Suppose I give you a simple molecule like this, and you know this is called acryl aldehyde. This is basically CH2, okay, CHO, okay. Now you're going to first find out if it is coming from a aldol reaction, can be a cross aldol reaction also. So you got to find out the alpha beta bond in respect to the CHO group. Okay, I'm just using line diagram, so I'm not drawing the hydrogens on here. All you have to do is disconnect on the alpha beta bond, keeping in mind that while disconnecting, I will keep the negative charges. I will keep the negative charges over this carbon, that is the alpha carbon, and the positive charges will be over the beta carbon. Okay? If you do so, and apply what I have taught you already, when there is negative charge, add what? Hydrogen. So plus 2H plus, that gives you CH3, double bond OH, and here it gives you C double bond OCH2, that is your formaldehyde. Over there you have your acetaldehyde, and that is your starting material for the compound. Let's see if this is really applicable to other things or not. So now I'm going to take a proton aldehyde, okay, and now again I have to look for the alpha beta. This is my alpha, that is my beta. I will disconnect and keep minus where? On the alpha carbon. So this is my minus, minus, obviously keep writing CH, okay, just to get used to it, because this is a new idea for you now. And then CH plus and plus. So these are your xanthons. What do? You add 2H plus, so this becomes CH3, CHO, and that becomes CH3 after addition of what? O2 minus, this becomes CHO. So these two molecules, or simply the acetaldehyde combining with another acetaldehyde, gives you a proton aldehyde. So this is something that is happening between two different molecules. So it is basically, you've got to apply over here and think in your mind that here the reactions are, so basically this, if you're treating with dilute NaOH, is going to give you this molecule. Alright. So if this is giving this molecule, then the reaction that is taking place over here, you have gone backwards, now you've got to go forwards and prove that you're correct. If you're going to do it, so we will say, so there is